All right, so let's take a look at problem number 8. We're given an equation and we're asked to determine whether this is an even, odd, or neither function. We don't have the graph. We could sketch the graph and try to answer it from that, but when you're given the equation, typically they want you to use the algebraic definition to determine whether the function's even or odd. All right. So our first step when we're given the equation is to evaluate the function at the opposite of x. But I always take time to first just see if I understand what the function does. This function takes the input no matter what you give it, and it creates an addition problem, where the first term is the input cubed. Whatever number you give it, whether it's something easy like 0 or some complicated expression, it's going to take it and it's going to raise it to the third power. Then the second term, it's just going to double it, whether it's something simple or whether it's something complicated. The input that we want to give it is not x, but the opposite of x. So if we give this the opposite of x, it's going to create this addition problem. It's going to cube this opposite of x, and then it's going to double it. So let's take a look and see what the expression simplifies to. If I have a negative base raised to an odd power, that's going to be a negative number. And this addition is now going to change to subtraction. I can clearly see that this is not an even function because this f evaluated at the opposite of x is not equal to f of x. For even functions, this would be equal to each other. This expression would be identical to the one we started with. So this is not even. Now, if we take the opposite of this, will it become the original function? So if I am interested in the opposite of f evaluated at negative x, well, that's like multiplying both sides of this equation by negative 1. If I take the opposite of this first term, I get x cubed, and the opposite of subtraction is addition, and I get plus 2x. And I can see, hey, those are the same expression. Okay, so I can say this is an odd function. That when you take f evaluated at negative x and you take its opposite, you'll get back the original function. So that's an odd function. Alright, hope that helps. Oh, we said that we had a shortcut. I forgot that last time too. If I look at the exponents, those are both odd. Now, for odd functions, if I have a constant term, it has to be 0. If this were adding 1 or subtracting 1 or just any non-zero value, it would ruin it and it would not be an odd function. But since these are odd and we're not adding a non-zero constant, it's an odd function.